is always the hardest part, getting started. Good morning, guys. My name is Stephen French, and welcome to part 2 of Let's Clone Space Invaders. If you haven't... come on. Logitech. Already starting with this? If you haven't seen part 1, please go back and watch that. It'll catch you up to where we are with the code, and that just makes sense to follow with part 1. If you've seen part 1, buckle up. We have a lot of coding to do. I will try to make this as quick as possible, so let's get right to it. Alright, today we're going to be adding in the enemies, adding in the enemy AI, and yeah, hopefully we can finish that all in this part. Don't want to split it up any more than that. So let's start off by adding in the sprites that we're going to need for this. You will have all of them in the file that you downloaded in the last episode, or just check the description for the link. So, sprites. Add a sprite. Serious? Add a sprite. Sprite underscore, what are we working with today? Alright, we need to add the lasers first. So we're going to add enemy laser. Let's go with the bottom laser. I'm sorry, that's super annoying. Load. Where are we at? Desktop. Space Invaders. Sprites. Enemies. So we have enemy laser bottom 1, enemy laser bottom 0. Good. Open those up, center it, we're done. Duplicate that. Sprite, enemy, laser, mid, load. There's bottom 1, bottom 2, so this is mid 0, or yeah, mid 0, mid 1. Edit, make sure those are in there. Sweet, center, done. Duplicate. Sprite, enemy. Again, you can name these whatever you want, just this is what I like to do. Enemy laser, top. Load, same thing, we have top 1, top 0, center, done. Good, so we have all of the enemy lasers that we need. I should have gone ahead and put these in a group called enemy, but I didn't, so we'll do it now. Drop that in, drop that in, drop that in. Good, now we're going to actually need the enemies. Sprite, enemy, bottom. Load sprite, we have bottom 0 and 1. Center it, done. You get back in there. You go up. We have sprite, enemy, mid. Load sprite, where are you? Sprite, enemy mid 0 and 1. Centered, okay. Drop you up in there. Why aren't they going where they're supposed to? Sprite, enemy, top. Load sprite, scrolls. Enemy top 0 and 1. Done. Go there, that's annoying. And lastly, sprite, enemy, UFO. Load. We have UFO and we have UFO's death. That'll make more sense when we kill him. So we have all of the sprites that we need for this episode, or for this part. I don't know why I keep calling it episode. I guess it works. So, enemy, we have the lasers, we have the enemies, we have the UFO. Now let's go down to our objects. We're going to make that same group, create a group enemy. I capitalize it because I didn't let go shift. Alright, so get rid of this, get rid of this, get rid of this. We're going to add an object. We're going to start off with the laser, because once we get to the enemy, he's going to have all of his information to shoot, so may as well have the laser already done. So object, don't capitalize that, at least I won't. Enemy laser. And we have... Alright, yeah, we're going to use only one object for the laser. Even though we have 3 different types of sprites, we only need one object because the enemy, the code itself will determine which type of laser each enemy is using. So we're not going to worry about that right now. But you can just give it a, pick any of those sprites just so you can see it and we know what it looks like. So we have the object enemy laser. Like pretty much everything else, we're going to give this a create event, come down to control, execute code, and we will initialize variables. That's not how you type. Or it's another one of those days. I guess every day is that. So we're going to have a speed variable, set that equal to 1 for now. We're going to have a damage variable, which can be 1, and an image speed. I don't think we've used image speed in the last part, because I don't think we needed to, but image speed controls how fast we're going to cycle through the sub-images. We can do this manually, or we can do this just with the image speed variable. I will actually be using both methods for this part. So, laser has those three variables. Let's come down to our step event. We're going to need one of those. And in the step, we're just going to have move, like that. All we need is for the laser to travel down the screen. So y plus equals our speed. So again, that's y. The y coordinate is equal to y plus our speed variable. Plus equals is just shorthand for that. So we have that. Now we need a couple collisions for what this laser is capable of hitting. So add event collision. We're going to collide with the player. Execute code. Collide with player. Right now, so I mentioned before the width option, or the width function. So we're going to do that now because we need to handle some of the player's variables right before this collision finishes. So width object underscore player. You see it's red, so GameMaker knows that we're talking about something useful. If our player is alive, then we are going to say that alive is equal to false. So if he's alive, we are killing him. Oh, my bad. We need curly braces. We're doing a couple things with the player. So if the player is alive, set it to false. Lives, minus minus. We didn't use lives last time. We're still not really counting them, but lives, as we mentioned before, is a global variable, so we can access it pretty much wherever. I don't even think we need it in the width, but we'll do it here anyways. And then we need to set the player's alarm 0. Let me just make sure that we went back and actually wrote that alarm. We didn't. Why didn't we? All right, so we're going to set this and then we'll come back to it in just a second. We have to actually update a couple parts of the player. So just follow along for right now, and you'll understand what this means in a second. So live player is equal to respawn time, which we actually did set before, I'm sure. And that's all that we need to handle with the player from here. After that, we can kill off the laser. And we're good. So that is done. Our collisions with our player is all set. We have to collide with the barricade, which is still spelled wrong because I'm not going to change it. With the environment, barricade, and this will be pretty much identical, if not exactly identical, with how the player's laser collides with the barricade. So, oops. Collide with, we all spell it correctly here because we know how, we've learned. So other, which is the barricade, .hp minus equals damage. So the barricade will just be going down in health, we've already done that, and then instance to destroy because we don't want that laser to stick around. Now same thing we did with the player's laser, we don't want it to go outside of the room and still be counted. So just outside of room, instance underscore destroy, and that'll take care of that. Good, so now we've done something weird. We've collided with player and we've added this alarm 0 equals. If I didn't mention what alarm did, I'm sorry, it was a couple days ago that I recorded that. Alarm is basically a timer. We're just setting an alarm. Whatever number we've given this, which the player's respawn time should be set, yes, to 30. Every frame that'll go down by 1. Once that hits 0 or possibly -1, the alarm will trigger. So let's go back into our player and actually set that up. So first let me just find my actual code. Good. So in our player, we're going to add an event, alarm, and alarm 0. Which alarm you use doesn't matter. I just prefer to go top to bottom. It makes a little more sense to me. So this is actually used to respawn the player, as I'm sure you've already guessed. So after we're dead, we're going to set this alarm to 30 frames. After 30 frames, it's going to call. First thing we need to do is we're setting the character's state of alive back to true. So player is alive again. We'll call the sprite index to be equal to the sprite player. I don't know if we did this before. Damn, I forgot a lot. When we die, we want the player to change over to his death animation. If we didn't do that before, we'll do that. It's nothing tricky. It's basically exactly this. We are changing the sprite index, meaning that Our player sprite, yeah, we don't have a death animation yet. So we will change it when the player dies. His sprite index is not pointing to this green sprite, it'll be pointing to another one. Yeah. So that'll be taken care of later. For now, either way, even if we haven't changed it, this will just reassure that it's set back up to sprite player. Now we need to give the player, put the player back to where he started. Now you could do this by finding the room width and setting it to the middle, and finding the height minus however far from the bottom you want to be. I like to just set it in a particular coordinate. It's, I don't know, it's just what I feel like doing for this one, since the room won't be scalable and the room is just whatever size that we've made it to be. So we're going to set his x coordinate equal to 288 and his y coordinate equal to 384. That is just the center of the window, but down towards the bottom. And that's all we need for that code. So now if our player dies, he's just set back. Good. So for sprites we've done. Enemy laser we've done. Good. So our laser's done, our player is updated, and now we actually need to make the enemies. So we're going to do this with inheritance, if I could ever get into this folder. So we're going to insert an object, object underscore enemy. Now don't set a sprite to this. Well, you can if you'd like. I prefer just to leave a lot of my parents as empty boxes. That's just what I'm going to do. Add a sprite if you'd like, doesn't matter. And we're going to have quite a bit in this create event because we're going to keep all the variables that each enemy will have. So go down to control, execute code, init variables. All right, so we're going to separate these into kind of the player's laser information and the player's self information, so to speak. So we'll do that by just making laser info, infor, and player info. Ah, damn. Enemy info. Good. So for laser information, all right. Yes. So for laser information, all of the variables will be prefixed by laser. Just make it a little easier for us to read. So laser underscore speed is equal to, say, 5. That actually doesn't matter. You'll see why later. Laser underscore damage is equal to 5. Again, doesn't matter yet. I had it 1 before, so I'll keep it consistent. Fire delay is equal to 120 plus random parentheses 900. So now what this did, I chose these numbers somewhat arbitrarily, just kind of trial and error to find timing that I like. Now, these enemies will be firing at a seemingly random time. So they might shoot a little faster sometimes than others. How we're handling this is we're setting this will be used for another alarm, so another delay. We're setting it to a minimum of 120 plus a random number between 1 and 900. That's just GameMaker's function for random. Again, if you middle click, you can see how it works and read up about what exactly is going on. And they give an example of how to use random. So fire delay is equal to 120 plus random 900. So the largest delay we'll have will be 1020. The lowest that we'll have is 120. Now we're actually going to set in this create event, because remember create event only runs once. We're going to set alarm 0, because this enemy's alarm 0 is different than the player's alarm 0, is equal to fire delay. And lastly, we're going to set which sprite index is used for each enemy. So laser sprite is equal to sprite underscore enemy laser bottom. Doesn't matter yet. We'll get into why in just a second. So now we have our enemy information, so the information about the enemies themselves. So we're going to have a direction, which we'll set equal to 1. We will use that for when we're traveling to the right, as x increases positively to the right, which I'm pretty sure is, I still don't remember how my camera works. Speed will be equal to 6. This will actually be uniform across all of the enemies as well. Can move, which is a Boolean, is going to be equal to true. Sorry, I keep looking over. I forgot which way I like to start these variables. And there's a couple variables. I did a few things that we don't need to work on in this project at all, so we're not gonna. All right, so we need a drop height and points. I may as well not change this up. Drop height is equal to 12. This is going to be how far down the screen we move, because all of the enemies will move over, drop down simultaneously, and then move back. So drop height will be equal to 12, and points will set equal to 10. Now, some of these variables don't actually matter that they are, like the variables themselves, the values don't matter because they will be changed with each enemy. But this is an example of how inheritance works. We're going to set this object as our parent to our other enemies. So when we make the other enemies, they already have those values. And if we need to, we can overwrite them in each enemy or each enemy type. But we do need a little more than just a create event. We've set an alarm 0, so we need to actually create the alarm 0. Good. And this alarm will be used to fire the lasers. All right. So when alarm 0 hits, or when alarm 0 reaches 0, or it's ready to actually trigger, we are going to have to create first a laser. So we're going to do laser equals instance underscore create. Same as with the player's laser, we're going to create them right at the origin of the enemy. So x, y, object underscore enemy laser. There we go. That's why we've already created the laser first. We're going to laser dot sprite underscore index. This is why we've created this sprite index variable in the create event, because now we can just go to laser underscore sprite. So whichever enemy sprite, whichever sprite the enemy knows it needs, we can apply right here. Do the same thing for damage. Laser dot damage is equal to laser underscore damage. And laser dot speed is equal to laser underscore speed. Now, if you haven't caught on necessarily, dot and underscore are different. Underscore damage, this is just one variable that we gave this entire name. You can use some special characters such as underscores in your name. Dot, on the other hand, is a little bit different. We've created an object called laser, and it's actually a laser object. So this now pertains to this object right here, or an instance of that object. Since that object has a few variables of its own, all objects have a sprite index, we can just access that object's variable by adding the dot. So laser dot damage is directly referring to laser create event this damage right here. So we're just updating those. That's why, whoops, that's why they didn't matter earlier, because we're changing those with the enemies themselves. Good, and only a couple more things are needed here. So in this alarm, after we've shot, we need to reset the fire delay, so that way it can go through again. We'll do fire underscore delay is equal to, and we'll make this a little bit slower this time. So we want the enemies to shoot earlier, like when the game starts, we don't want them to wait very long. So we're going to do 250 plus random of 1500. This is going to give us a much wider range. So right away in the game, we'll get a few enemies to shoot off pretty quick, and then it'll be widely dispersed. So there's going to be 55 enemies on the board, all shooting at random times. That way it makes the game a little bit harder. Now, if you want to make these games harder, this is where some of your freedom plays in. You can make them shoot as fast or slow as you'd like. You can make it just rain bullets, and it's actually kind of fun to play with. And then we just need to set the alarm itself over again. Alarm 0 is equal to fire delay. And bang, we got it. I keep saying bang. That's a slarm. Alarm 0 equals fire delay. So the alarm is done. One more step, well, one more event, it's going to have a couple actions, is we need to add the step event. That is totally how you spell alarm and not step. So step, create code, and let's title this one, we need to do 2 of these, so let's see which one's first. We'll go to move first. So we're going to tell this character to move. Now this is a bit weird, because what we're doing here is actually not moving the object. GameMaker is a little silly sometimes in how you work with a group of objects as a whole. So we're going to be referring to these enemies programmatically through the parent enemy class, which is what we are actually writing still. So each enemy is going to be referred to not directly, but as a result of its parents. we're going to create another object called system in probably just a few minutes. The system event is going to be moderating, I guess that's not even, yeah, it's going to monitoring, there we go, wrong M word. It's going to be monitoring the speed of the game, the time of the game, and everything that's going on, and it will be telling the parent object, the parent enemy, to move, or rather it'll be telling the parent object when it's allowed to move, and then all the enemies themselves will listen accordingly. So what we're going to do here for move, we're going to say if can move, which you should remember is a variable that the enemy has itself. We'll do x plus equals speed. Oops, I'm sorry. Speed times direction, because we need to be traveling left or right. The times looks a lot more like an asterisk. Speed times direction, speed times direction, and can move is equal to false. This means that every time we move, we immediately want to stop moving. We want to move over one spot, stop there, and wait for further instructions. So, can move is done. We're going to add in another event, or rather another action. And this one is going to be check for walls. Why would I do that? Check for walls. Now, the same type of problem occurs when trying to communicate back and forth from the system, or rather, the same problem occurs, which is why we're using the system to communicate, in that when an enemy touches the outside wall, when they've reached the edge of the game, we need all of the enemies to turn around. If each enemy did this on its own, one will get to the end, start turning around, while another still has to wait until it's to the end, and then turn around. Now, originally I tried just going to the end, updating the parent object, and then expecting them all to move, which worked, although whichever enemy barely touched the edge first, so whichever enemy in the topmost row, that one got read off, because everything's sequential and linear, that one read off that it was touched first, and it would change directions, while all of the others were still a little bit behind. So one enemy would pause and move, and then the rest would move, and then it would be a little bit off, and then they would all start going, and it got really, really weird. So instead of doing it that way, we are just going to have the system tell us when we're allowed to. Nobody's allowed to move until the system says, yo, you can move, and that's what we're going to do. But when we check for walls, we still want any of them that touch the wall to give the system the update, saying, hey, one of us hit a wall, we all need to stop, type of thing. So that's how we're going to do that. We're going to say if x plus 32 times direction. I'm going to type all of this out, and then I'll explain it a little bit. I'll explain all of it after. Is greater than equal to room width, or I'm just looking to the side because I have all the code written out and I don't want to make any more typos. X plus 32 times direction is less than or equal to 0, and direction is less than 0. So under these conditions, which I think I have typed out correctly, which I'm now certain more than ever that I haven't, unexpected symbol and expression. What did we do? What did I do? Oh, that was dumb. Greater than equals to has to be the same. I'm sure at least one of you saw that before I did. Now, so what this means is that the X, remember we've centered all of these images. Oh wow, I didn't. So these have been centered. So this plus is in the middle of the image itself. This image is 24 pixels wide, so the center is 12 and 12. So we're saying X, so right in the middle of the image, plus 32 pixels times direction. So if our direction is 1, that means we're traveling to the right. It should look like my right. If the direction is 1, we're traveling to the right. And if we're traveling to the right, we want to check ahead of us. So we want to check that X pixel plus 32, because we don't want to actually touch all the way up against the wall. At least that's not what a lot of the other clones that I've seen in the game itself. Doesn't look like they're touching the wall. So we're going to actually check until we're close to the wall, or at least close to room width, and then we're going to turn around. So we're going to check for that condition, or if we're going in the negative direction, we'll be checking for when X plus 32, or plus a negative 32, so 32 times minus 1 for when we're going to the left, is less than or equal to 0, because the room is on pixel line 0. And in that case, direction has to be 0. Now we need to update the enemy object, or at least the parent objects. So with object enemy, we need direction times equals -1. So if we're going to the right, we need to swap, go to left. Going to left, swap, go to the right. Easy enough. Then with, that is again not how you spell the thing that you want to spell. We don't have this object yet, but object system. We need drop equal to true. Now, obviously we don't have the object, so we don't have the drop variable, but that's just going to basically say if drop is true, I hate my phone. If drop is true, then we can call back to the enemy object. It's going to be a little confusing. Everything's bouncing back and forth. So take my word for it for now. It'll end up working, and then just if you need, read through it again and again, or if you have any specific questions, please ask and I will answer. So this step is entirely done. I actually want us to check the wall before we move. It's just a little safer to get whatever you need done first. So if we're moving and then we check for wall, we might actually move a little too close. And we're done with that. We can move on to actually creating the enemies themselves. Okay, now this part is going to be a little bit tedious or repetitive. So I'm going to create one of the enemies, and then I'll pause. You guys can catch up to the rest. And, well, I'm not going to pause. You guys can pause the video and catch up and add the rest. So we have object, create an object. Why don't we just go in here like I want? Can we please? There we go. Object, enemy, and I always start with the bottom first. You don't have to. We're going to give this one a sprite, enemy bottom, and we need to set this parent to enemy object. Super important, in other words, none of this code works. Now we need to add a create event. Control code. Now, as I've said, the parent, first let me just title this, init variables. An object will take any of the information that the parent has, but in GameMaker it's a little bit different. So here we have an enemy bot, or we have a child of the enemy object. So we would think that it would have this same create event, which it typically does. But if we create a create event here, sounds funny, if we make a create event and we give it its own code, it's actually going to paste this code over the parent's create event. So we're going to lose those variables. But we can get around that by doing something that GameMaker already has called events inherited. Is it event? Event inherited. Basically what that does is any code in a parent create event is now pasted into this line first, and then from there we can add on our own information. So since we've created that, we can now update with the enemy what we need. So a few of the variables that will change between the enemies is laser_damage. For the bottom layer, he will be the weakest of the enemies, so his damage is only going to be equal to 1. Oopsies. Laser_speed. I'm not sure if the speed is all the same. I don't remember what I've made them. If they were all the same, we wouldn't need to do this, so I imagine that they will vary. So laser speed for the bottom layer is going to be 5, or for the bottom enemy. And laser sprite. As I've mentioned before, this will be different for each one. We're going to do, sprite, sprite enemy laser bottom. Perfect. And lastly, we have points. Points is equal to 10. From here, we need to add 2 more enemies. We need the middle enemy and the top enemy. So you can just duplicate these. You'll have everything set up as is, but we need to change a few of the variables. So from here, we're just going to go into enemy bottom, duplicate. We need to change the sprite so that way this is actually the middle enemy, and we'll call this object enemy mid. Now a couple of the variables are going to change, and we will do that now. So the damage for the middle enemy is still 1. That hasn't changed at all. Its speed is going to go up to 7, so this one is a little bit faster. Now I actually spelled out bottom, but did mid instead of middle. I'm not consistent. And so these guys have a different sprite, and they're going to be worth 20 points as opposed to 10. So let's do that one last time. Duplicate. Oops. Object, enemy, top. I'm going to give him the top. Oh, that's a laser sprite. give him the top enemy information. We're going to come back to here, and we're going to give him a damage of 2, a speed of 10, a sprite of the top enemy, and 30 points. The top row is going to be worth the most. So now we have all the enemies created. We can put them into the room and play around with them a little bit just to see if our code works. We're also going to figure out how many typos I've made, as I'm sure there are some. So let's go back into our game room. We're going to go to Objects, Enemy. Let's just make one of each. So let's make a bottom enemy. Let's make a middle enemy. I don't know why we're not going to put them... Actually, we'll keep them centered here. So we'll keep them in the middle. I have, since the last episode... I keep calling it that. Since the last video, I just spaced these out evenly, and I placed the player on that same coordinate that we've used. So the player is on, because of these lines, it's not going to say the same, but I think it's 288 by 384 is where the player is sitting. So I have those two guys, and top will be last. Good. So we have our enemies, we have our room, we can hit play. Oh, hopefully we can hit play. Let's see what I've done. Oh, sweet, everything works. So these guys are moving hella fast. That is actually not an issue right now. I do want to set their speed to 0. Whoa! Oh yeah, player, he actually died. I couldn't move for a second, but we haven't set up his death animation, so that is fine. So we have these guys, they're booking, and that's fine. It doesn't matter. But if we shoot these guys, nothing happens, because we do still need to upgrade the player's object. The player's laser object. So I'm sorry, I forgot that one. When we made the player, we didn't have any enemies in the game, so we did not make a collision for them. So we're going to collide with the parent enemy. And we've actually got to do a few things here that really don't matter. And this will give us some bugs, but it's fine. So we will expect these bugs. Right here, collide, whoops, with enemy. So here. We need to update the system, which, again, we haven't created yet. Update system. We need to update the enemy. Pretty much just so we can destroy the enemy. And we need to update the player. Oh, well, yeah, player, self, however you want to call it. Good. So updating the enemy is the easiest one. For some reason, whenever I try to do other instance destroy, it doesn't work. I'm not sure why. So we're just going to do with other instance destroy, and that works just fine. I'm not really sure what the issue is there. So we're going to update the player in a similar manner. We're going to update, oh, not the player, I'm sorry. By self, we're updating the laser, so instance destroy. So just to test how shooting works and just to make sure that the laser does in fact kill the enemy, we can test. So they're booking, we're gonna shoot, and bam, he's gone. Shoot, he's gone. Shoot, and he's gone. So that works out pretty well. Now one thing I forgot to do is to go back into the enemy object, go to the create event, and we need to set the image speed equal to 0, just because the little guy's legs were freaking out. And we don't want them to move at all yet. We're going to handle that actually in the system object as well. But before we make the system object, we are going to make the UFO. This one shouldn't be too much. Object UFO. I'm going to give him his enemy sprite. Keep in mind his sprite actually had not a death animation, but there was a red and a white one that we're going to use for the death animation. So in here as well, we want to make a create event and we want to make that speed 0. Init variables image speed is equal to 0. That is a 9. We're going to have a few different things here, not very much. So how the UFOs work in Space Invaders is that the UFOs have a not random, well, it is random to a degree. There are a few different valuables. There are a few different amounts of points that a UFO can have, and which one it is random. So we're going to do a choose, which is pretty simple. Whatever numbers we put in here, it'll randomly choose one of. So we have the options of 100, 150, oops, 200, 250, and 300. So either with the UFO, when they go across the screen, will have one of these point values. Next, we have direction is equal to 1. We have a speed equal to 3. So good, we have those. And our UFO needs a couple more bits of information. So next, all we need is a step event. This step event will just be to handle the movement. So from here, we're just going to say, x plus equals to speed times direction, similar to how everything else is moving in this game. And lastly, we just want to make sure that when the object goes outside of the room, just like the lasers, that it dies. So outside of room, instance, destroy. But we don't want to collect points for that, so we're not going to handle any of that here. And that's all that we need for the UFO. So now we can jump into the system object, which will be the last thing that we're working for today, or that we're working on today. So enemy. It's actually not an enemy, so it's a good thing that that missed. Object, system. No sprite is needed for this. But we do need a create event, and it will have kind of a bunch of stuff. Not a super bunch. Initialize. Whoa. I am getting bad at typing, and I'm getting pretty lazy. So we're going to have the information for a few different things. So for starters, we're going to have the information for enemy movement. So again, the system is controlling when the enemy can move and when it drops. So we're going to set that drop boolean to false, because we don't need to be dropping out of the sky right away. We're going to set our move delay to, I believe I had 25? I did, 25. And we're going to set an alarm 1. I'm not starting with 0 because that's actually going to be for the UFO code, but we're not doing that quite yet. Alarm 0 is equal to move delay. And that's daily. That is not a method. There we go. Move delay. And our speed is equal to 15. The next information we need is more of the system's typical job. So we're going to need some of the game information. Information such as a game over variable, which will be equal to false because the game does not start over. We have an enemies total, which will be set to 55 because that's how many enemies are in the game, but right now we're just playing around with 3, getting this code working. We will have a number of enemies on the map, which enemies is equal to enemies underscore total. And we have a total number of points, which when we start off, we don't have any. So points is equal to 0. And that's all we need for the create event. For now, we will be coming back later. So now that we've created that alarm for the enemy, let's jump into alarm 1 and start that up. Remember, this alarm was for enemy movement. And we need to update the enemy's position. Good. So we need to know if enemies is greater than 0, because if we don't have enough enemies, or if there are no more enemies in the game, then why are we still playing? Or more so, why would we tell them to move if they don't exist? So if enemies is more than 0 and the game is not over, so we're going to use that exclamation point as a not, game over. I believe I used a camel case. I'm not too consistent with that. Almost did something else dumb. So then from here, we'll say if drop is equal to true. Well, because by saying drop equal to true, that would come up as a true statement, but since it's a Boolean, if we just say if drop, that will come up as true if it is. Then from here, we need with object enemy. Remember, we're pointing to the parent class now. Y plus equals to drop. I really hope I did drop height like that and not camel case. I tend to go between using this type of structure when spelling and this type of structure. I go back and forth a lot and it screws me up, so try not to do that habit. Y plus equal to drop height, and then after we've made that drop, we want to set drop back to false, so we're not trying to drop again. And then still in this check, so we still want to check only if there are enemies. We're going to set up an else. So it's if drop is equal to true versus if it is not equal to true. If it is not true, meaning we don't we don't want to drop, then we want to just continue moving. We only want to tell the enemies to move when they're not at a wall, or rather when they're not dropping down. So they're going to move over. Once they hit a wall, they're setting that variable drop to true. System's going to look at that, saying if drop is true, then we're going to tell the enemies to drop down a little lower. If that is not true, then we're going to continue moving. But the enemies aren't moving on their own. They're waiting for the system, or right now, I guess us technically, to tell them when they can. So we're going to do that here. So we're going to go to object underscore enemy dot can move, and we're going to set that equal to true. Remembering that back in the enemy class, when that is set to true, we're going to move over towards the direction that we're going, and then we're going to set move to false. So we're only going to move once really, really quickly. That'll only happen in one frame. Now, this is the reason why we didn't set the image speed of the player, or of the enemies. We could have timed it just right, which actually comes out to image speed of 0.04, because I played around with it for a while. But we want them only to kind of change their animation as they move. It's a little easier to do from here. Also, since it's a different way of doing it, it's good to look at. So we'll do update enemy animation. Now, again, we are inside of these systems, so we need to be looking at with object enemy. We're going to say that if, now this is all of these variables are going to be game maker variables that will be read by nature, and they're just dealing with the same thing as like when we looked at the sprite index or the sprite image of what it was. We're going to say image index, which refers to which sub image we are currently on. So if the enemy has two images, one with their legs in, one with their legs out, we're going to check which one of those we're pointing to. So if sub image is equal to image underscore number, which is referring to the number of sub images there are. So we're checking to see if our current sub image is the last sub image, meaning that we want to loop back to the beginning. So if image is equal to sub image, then image index is equal to 0. We just want to set it back to the beginning of that animation sequence. We're going to say else image index plus plus. We're just going to increment by 1. So we have two sub images. If we're on 0 when we move, we're going to set it to 1. And then if we're on 1 when we move again, we're going to set it back to 0. And it'll just, every time we move, ticking between sub image 0, sub image 1. Should look pretty smooth. Now, after all of this is done, we want, well, again, we are actually in we're in an alarm right now. So we only want this running every once in a while, which we have already created a variable for. So we're going to set the delay. Alarm 1, which is the alarm that we are in, is equal to move delay. And there we have it. The enemies should be moving continuously. The last thing we want to do is make sure that we can win the game. So we're going to, I don't want this to be a begin step. We're going to change this as a step event. And we'll say win-lose, although we're not going to worry about losing conditions right now. So for this, we're just going to check out the win. So if enemies is less than or equal to 0, again, we're just being careful such that enemies doesn't somehow jump from 1 to -1 just under some random iteration. You could foreseeably see if the laser goes into the object at such like an odd time between frames, it might read that collision twice. It's rare, but it can happen. Silly stuff happens all the time in programming. That's just what it is. So if that does happen, it'll drop the enemies down. I'm pretty sure that will never happen, but it's better to be safe. So now eventually we're going to use this part of the code to kind of reset the game, because in Space Invaders, when you kill the enemies, they just respawn and then you keep going from there. But we're not going to do that. We're just going to have a window pop up saying, hey, you won. So we're going to say show debug message, which is actually not what we want to do. Show debug message is a super useful tool that we won't be using right now. All that it is anything in here. If you just say like winner, anything that is called on this method will just be posted down here. So you know, we'll do both. We'll do a winner down here, and then we'll do the one that I was intending to do. So then we'll do a show message, a little bit shorter, and we'll make this one say you win. Yeah. And now what this will do is it's going to pop up a window, and it'll have a button attached to it. So it'll just say you win, you hit OK, and we're going to do a game underscore restart. and that's just going to completely reset the game. But that will be resetting the points, so that's not what we want to do in long term. So let's run this. Let's see what's happening. Ha! Silly me. So like everything else in GameMaker, we can't call them, they don't actually exist unless they're in the room. So even though this is an object that doesn't, we won't see it, we won't actually use it, it won't be a part of the game internally, we need to add it to the game room. So you're going to do object, or add an object system, and just put it in the corner. I usually just put it up far in the corner, and it can stay there forever. So that was pretty silly of me. Now, if all goes well, I didn't type anything wrong, and good. Our enemies are moving, just like they should. We don't have a points counter, but they are shooting. As you can see, they can hit the barricades, and they're moving pretty slow. Too slow for me to hit them. So we got 1. Come on. Turns out I'm very bad at Space Invaders. 2, and we got 3. And bam, we have a show debug message saying winner. We have, let's get this back up. Oh, well, I guess minimizing it makes it go white. You win with a button. This is just the show message. Hit that, and we're set up to go again. So that is awesome. We are just about done for this episode. We can super quickly add the UFO, and then we'll call it quits from there. So let's do that hella quick and get that done with. So all of this UFO information will be done in system as well. That is not what I wanted to look at. Why are we there? So let's go to object system. We're going to go in the create event, and we do need to add a couple pieces. This is actually for the enemy information. There will be a few more things that we're adding, but just not today. So enemy information rather than enemy movement. This is going to be the UFO delay. I can't type. And we're going to set this up to be random as well. So, and this is just a delay in spawning the UFO itself. So we're just going to choose a number between numbers that I found work were 500, 750, and 1000. Those are the numbers that we're going to use for the actual game, but for right now, we'll keep those in mind and we'll just make it a lot shorter. We're just going to set it to 300, end and close. So every time the delay will only be 300, but this is the code we will be using later on. So we'll just keep that there for now. On top of that, all we want to do is set the alarm 0 equal to alarm delay, or UFO delay. Good. Come back here. We're going to create that delay, or that alarm. And we have, this is the UFO alarm, UFPO alarm. I'm not sure what the P stands for. Now, we need to randomly choose whether or not we want the UFO to appear from the right or from the left. So we're going to give that X is a variable that's already taken. So I'm just going to call this XX, as we're just trying to find the X coordinate. You can name it whatever you would like. We're going to set that equal to a random choose. And we're going to choose that between -16, because we actually want this to appear a little bit outside of the room, although this isn't far enough outside of the room for the entire object to be out. So our UFO is 32 pixels wide, so 16 will actually be on this, this edge pixel, so he'll be right on the end. They're going to count that as still in the room, as the part of him will be on the pixel line 0. And our other option is for room with +16. Same thing, just being on the other side of the room. So we have that. We're going to have a UFO is equal to instance create. We're going to set him to his new X coordinate. We're going to set him at 32 pixels from the top, just what I chose to look all right. We'll give him the actual object of UFO. Now we need to give the UFO his direction. So if XX is equal to -16. Now one thing to keep in mind here is if we're doing an if statement, if I were to say if XX equals -16, if, I'm speaking in English now, if XX actually equaled this, by having one equal sign, we're going to be setting XX to, we're just going to force it to be -16, and it'll always be true. So we want to do a comparative, which is just a equals equals. That's where a lot of bugs come into play, and we can avoid those. So if x equals -6 means we're starting from the left, we need to travel right. So we're going to do UFO dot direction. If you remember from the UFO object, we gave it a direction variable. We're going to set that to 1. We'll say else. Oops. We got to say that it is equal to 1. Else UFO dot direction is equal to -1. So we'll travel right if we need to, left if we need to, and we're good. Here we will go for the, did I do that capitals? I did. I think I did UFO underscore delay. More inconsistencies with me. Choose, and we will start this off. We'll just do the same thing. We'll just call it 300 for now. Yeah. Alarm 0, that is almost the letter O, is equal to UFO underscore delay. I just want to check to make sure that I capitalize UFO, because I don't want to deal with that if I didn't. I did. All right. Click play, hopefully for the last time, and see if we get this game working. Come on. Should be within, well, it should be 30 frames, so it should be about within 10 seconds? No, should be less than that. Cool. All right, so it was about 10 seconds, but something silly happened. System.ufo not set before reading it. That is in our alarm 0 line 6. Abort. Alarm 0 line, UFP. I'm sure somebody saw that. Cool. Alarm 0 is correct now. And give us 10 seconds, we should have some UFOs going back and forth. Probably should have chose a smaller number, just because. You'll actually notice that each of these enemies, you can see that they have different shots. But there's our UFO. I missed. That's going to be annoying. Give this another try. Oh, hit that guy. Oh, damn. That was really dumb. You know what? I'm going to leave this as a challenge. I will show the code in the next part, but we couldn't kill the UFO for a pretty simple reason. It's actually a mistake that I made earlier in this video when trying to shoot the enemies. So I'm going to leave that up to you guys to try to fix. If you can't figure that out, again, in the next episode, I will just post a quick shot of what that code should look like. So fun, we have homework. Either way, thank you so much for watching this video. Thank you also Logitech for interrupting the frame. And I hope you guys are excited for part 3. Part 3 will include mostly just going over the respawning of the enemies themselves. It's a neat way to use scripts, and that's just something I wanted to point in on. And I might keep that to a really short part just on scripts, and then in the last part we will work into kind of the user interface, cleaning up the game, giving us a start menu, counting our points, resetting the game when we win or when we lose, and simple stuff like that, just to make it feel like a game instead of just some pointless shooting. So again, one more time, thank you so much for watching. It really means a lot to me. Feel free to like, comment, subscribe, share this video to anybody else who's interested in learning games, and please let me know what games you want to see made in this tutorial series. I've got some plans for the upcoming games that I want to do, but I'm willing to push those around to see if there's any suggestions. So have a nice day, and I will see you guys next time. Or rather, you'll see me. I'll still just be seeing my camera. See ya. Hey, who the fuck is texting me?
I'm not a popular kid.
What do you want?